Well, good afternoon, Energy Rogue Nation. Welcome back to another weather discussion. Thank you all so much for tuning in. Since I have been traveling out on the road the last couple of days and really haven't had the chance to do a weather video discussion, this one today is going to be pretty in-depth. The last few that I've done were usually in between about 10 to 15 minutes. This one will likely go longer than that because I want to cover all the bases in relation to Tropical Storm Debby. And as a matter of fact, the focus of today's video is going to be on this system. That being said, if you do have any questions about temperature trends over the next couple of weeks, be sure to ask those questions in the Energy Rogue Weather Discord channel. I'd be happy to answer those there. I will likely get back to some more temperature discussion, some CDD, HDD dialogue, probably in the next couple of days with the video content. But again, if you have any pressing questions about short and long-term trends, I'd be happy to answer those in the Discord. Other than that, as I advertised, today is going to be mostly talking about Tropical Storm Debby as she continues her, I guess I should say her, because it is Debby. we can refer by the corresponding pronouns, but Tropical Storm Debby is continuing to move off towards this kind of northerly direction. And as it stands right now on our GOES 16 IR, we have very kind of robust deep convection all throughout the outer bands of this system. Now, if you're wondering where the center is, I actually had to look into this a little bit more and see what the wind barbs look like to really pick out the center, because as you see right now, it's not really well defined. There's just a big, large wave of convection. But the center itself is somewhere within this area. You might be pointing to more north. You might be saying, well, Brennan, isn't it up here? Technically, it's a little bit further south. And the way we are able to derive that, which you'll see here in a moment, is by where our wind barbs or our winds are actually creating essentially a counterclockwise motion, which would take us somewhere within this region, indicated by this L that I drew here. So somewhere within there. Overall, though, really healthy convection. We've actually had a couple of different tornado warnings firing up across St. Pete, Tampa Bay, even up towards Orlando. We're starting to see some even supercell development on the outer bands of this convection. That's pretty common for these systems to see, tornadoes and some brief spin-ups. So I don't think that should be a surprise to any of us. But certainly the structures on some of those storms have been quite impressive. And just looking here at the infrared satellite, you can certainly see that we do have healthy convection. Because remember, the darker the colors, the colder the cloud tops. And the only way we get really cold cloud tops, as indicated here on our IR chart, is if our clouds are rising to really high heights, say 30, 40,000 feet. That's how we're getting these really cold cloud tops. And thereby, this is really showing us some very healthy convection, as I mentioned. Now, why it's not as organized is because you actually do have some dry air intrusion that's getting in towards the center, which makes this look more like a wave as opposed to a closed center. There certainly does exist a closed center, and this still by definition is a tropical storm. It's just a very messy tropical storm. But what we are anticipating is that as we go into the next really 24 so-ish hours, this area of Florida, right to the east of the Panhandle, the Florida armpit, is expected to see this system touch Category 1 status by the time it makes landfall. And you're going to see why that's the case here in a moment. But first, let's really break this down by looking at the latest observed, right? I am not somebody that likes to look at necessarily the models right away. I want to look at what has been observed by reconnaissance and essentially what the trend is on this system. So a couple things to point out. As a matter of fact, we just had a new reconnaissance mission just show up here as I'm doing this video. So I think it was drop 9 that had drier air, or was it drop 7? Let's see. Well, that wasn't too bad. Okay. I'm wondering where those drop-ons were, but I don't recall what mission this was. This would have been as of 1725 UTC. Just within the last couple of hours, this reconnaissance mission from the Air Force just went out and it did a cross-section of Debby. I'm trying to see, because, and I guess I'll go back to this later, but there was at one point with one of these drop-ons, we had actually more dry air intruding into the system. And how we knew that is because taking a look here at our dropsonde, for example, this green line here is your dew point, this red line is your temperature. Anytime you see it spaced out from one another, so your temperature line is spaced out from your dew point line, that's implying that the air is not saturated, and that's really more so speaking to dry air. What I was looking for in real time, as you kind of heard me talking to myself, was I was looking for a dropsonde that took place earlier in the day where rather than having relative humidity at 96%, it was more so like around, I think in especially the upper levels, about a kilometer off the ground, we were only looking at like 65% relative humidity, which in translation means there was quite a bit of dry air that was getting seeped into the center as we saw on satellite. But what we're seeing on these latest reconnaissance missions and these dropsondes is that the center is starting to consolidate more and is starting to become more saturated, meaning that that dry air that was previously intruding on the western flank of this system is really starting to decrease significantly. And so what this translates to, guys, is that we will likely see an intensification to hurricane status really within the next 12 to 24 hours as the system comes a lot closer to the shorelines of Florida, especially towards the Florida armpit. So I do apologize. I was trying to find that dropsonde. Initially, I thought that was going to be the one that came up, but it's actually one that shows a lot more of a convection consolidation taking place. And really that means that we're going to be seeing this storm as we are in real time actually intensifying and really starting to get its act together. Now, for those of you that are probably wondering to yourself, what exactly is a dropsonde? I've talked about this in previous videos, but a dropsonde is essentially a remote sensing device that when you fly over a system, so these reconnaissance missions, these Air Force planes, when they fly through the hurricane or a tropical storm, all they do is they literally just drop it. And what that will do is that then takes measurements of your wind speed at a certain height, your temperature and dew point at given heights, and then it also essentially calculates, well, I mean, that's pretty much it. Your temperature, relative humidity, and your dew point, but then it also plots for you the various heights of which it was recorded. The cool thing about these two is that they will also tell you where the location in the storm it was dropped. Sometimes it may say unknown, meaning that it's just no idea. It could have been any part of the storm itself. Other times, when we start to have more of an eye wall, the reconnaissance missions will try to cut through the center, or it'll even say eye wall, and that can give you a better indication on pressure towards the center, and as well as the magnitude of the eye wall itself in terms of its sustained winds. So that's essentially what a dropsonde is. It states it exactly in the name. You are literally taking a remote sensing in situ observation of the atmosphere within a hurricane or a tropical storm between a kilometer off the ground and what we would call close to the surface level. And technically that surface level is really 1,000 millibars in this case as a reference, but pretty much from the surface to about a kilometer off the ground-ish or so. So yeah, I mean, it's a pretty fascinating thing to happen. By the way, this information does get fed back into our weather models, and those sometimes can correct based on what's being observed, especially if a storm is expected to go through intensification. So that's our dropsonde data. Some really interesting observations here, and certainly pointing to an intensifying system as it continues to move northward into the Florida Panhandle region and the Florida armpit by the time we get to possibly as soon as later on tonight into Monday morning. Now, the other thing I wanted to show you guys as we talk through this is the intensity guidance. I'm going to touch more on this later on in the video, but one thing that I want to note is that whatever happens with this system as it goes into Florida, but especially the Carolinas, we are only expecting the system to be anywhere between, say, a tropical storm and a Cat 1. And why that is because, as we've talked about these last couple of days, these storms, especially Debbie, is going to be working with a lot of shear. And I'm going to show you that more here later on in the video. But just know we are not expecting a major by any stretch of the imagination. What has been a concern of mine over the last few days, and really these last several days, is the potential for the system to stall out. If this system was to stall out, say, over the Carolinas by next week at some point, well, then now we're talking about a flooding threat, a pretty significant one. So it's kind of like Beryl in that rather than its bark being bigger than its bite is going to be bigger than its bark. It may not look intimidating because we're not talking about a major hurricane, but just like Beryl, this is one of those systems that, is still going to be a problem. It's not going to be something that, is, can just totally ignore if you're somebody that lives in the coastal Carolinas or Florida or Georgia, right? Because if we're talking now about a stalling tropical storm, well, now that's a conversation about some significant coastal flooding and inland flooding that we have to be really keeping our eyes on here, and more on all that later. But this current product, nonetheless, is showing you the model spread of the magnitude of Debby really over the next week, and clearly the spread, very high confidence for a brief Cat 1 to a tropical storm. Now, something to note is that many of these models are not showing, Cat 1. But the one thing to note is that they briefly touch the Cat 1 threshold. I expect that to happen. And the National Hurricane Center also expects that to happen because, as you're going to see around coastal Florida, and especially the coastline of the Gulf, these areas are dealing with some very hot sea surface temperatures. The closer you get to shore, your sea surface temperatures will also increase with that trajectory. So as it does so, and as it moves further away from that little dry air pocket that it's in, we can expect this thing to hit Cat 1. It's likely not to stay Cat 1 for long. It will probably touch that threshold, and once it moves inland, will then weaken down to a tropical storm. But as I mentioned, and as I foreshadowed here today and also the last few days, our concern then turns to the Carolinas and even parts of Florida and Georgia for significant flooding threat that could arise from this. So this is just talking about the overall magnitude of the wind speed, especially when we're looking at storm surge concerns, if we're looking at straight line wind concerns. But we also have other hazards, remember, that come with these storms that we have to, of course, keep in mind. Here is also another product, and by the way, all these products are courtesy of College of DuPage, as well as, in this case, Tropical Tidbits. This is our current spread right now, and as you can see, very high confidence, not just in the magnitude, but also the pathing. And it might be very hard to see here. Let me see if I can zoom in, but there's something that's really important with this map. Notice that each one of these lines is corresponding to a given weather model, right? And an individual solution. Look at the Carolinas. Notice how these lines are not going straight out with the exception of a couple, right? They're all sort of consolidating and clustering near the Carolinas. That is my biggest concern right there. There is very high model confidence that this system does significantly slow down and at one point become almost stationary over a particular region. And we've also talked about why that is. It's because we have this high pressure out towards the Atlantic. Remember, high pressure spins clockwise. And actually, let me draw that here in pink. Let's do that so I can differentiate here. So your high pressure spinning clockwise. And then you also have, which you'll see here later on as well, our jet stream that's crashing down from the Midwest. We have high pressure off the page of this map, but then our jet, correlating with this arrow, is meeting up with that clockwise flow with our high. And they're both meeting up right at this point. And because of those opposing air masses, you not only are getting a bunch of shear within the Carolinas, which will help to weaken the system to a tropical storm and mostly keep it at that threshold over the Carolinas at that point, but also it's going to pretty much wedge it in the Carolinas and lodge it in that one spot. That's why there's very high model confidence that we're going to see likely a almost stationary tropical storm in the coastal Carolinas as we get to early to middle of next week. So very much concerning. Model confidence is high on that. I guess if there's, and I got to be careful in saying this, I mean, there really isn't any good news necessarily, but if there is somewhat good news from this system, it's a good thing that it's not going to be a major hurricane or even hurricane threshold once it gets to the Carolinas because of that crashing opposing jet stream that's going to bring with it a bunch of shear. Remember, these tropical storms don't like shear. They absolutely hate it. because it's wind opposing the flow. And so it's actually going to help to disrupt its strengthening capabilities. But again, here's my kind of caveat to that. It really, at that point, when you're talking about a stalling system, it really does not matter what the magnitude is. We have very high saturation with these kind of systems. They tend to precipitate a lot over a short period of time. That leads to long-term flooding, short-term flooding concerns, coastal flooding. That is the thing that worries me the most. I really don't care what magnitude it is, because remember, as I mentioned at the top of this video, and as many of you know, for folks that live in hurricane-prone areas, it doesn't always necessarily matter what the strongest winds are. You know, we're not talking just like a tornado. Tornadoes are only looking at wind. Hurricanes are wind and everything else that comes with it. So, there's certainly a lot more hazards that are on the table with hurricanes versus, say, tornadic producing cells that are limited to just wind and hail. So we have a lot of things on the buffet table to consider with this system, and despite its magnitude, that won't be the biggest concern, is the wind. It's going to be the flooding. So just wanted to provide some explanation on that, and these spaghetti plots really are a spread of all these models, as we just mentioned. And the fact that they are just all clustering and consolidating around the Carolinas and not moving as much over a period of 24 to 48 hours, as a meteorologist, that is one of the more concerning things you want to see out of a tropical system. And I'm not saying that to panic anybody, it's just the truth. You never want to see something like that. So, other products that I wanted to go over with you here, let me just make sure I covered my bases. I guess I'll show you the National Hurricane Center latest outlook. Quick disclaimer here. Be sure to check the latest from the National Hurricane Center. I'll be sure to post updates throughout the day today. But this, of course, video is coming out this afternoon as of 1 o'clock Central Time. So, of course, this is subject to change. But what likely isn't expected to change is the current trajectory of this system, which is expected to hit the Florida armpit. I hope you guys are getting sick of me saying that, because I love it. I think I've coined that term now. Anyway, system hitting the Florida armpit over the next 12 to 24 hours. I certainly expect this thing to get up to Cat 1. I definitely agree with the National Hurricane Center. The conditions present themselves. They are certainly there, and that is something that we have to watch. But this is the latest outlook as of 11 a.m. Eastern advisory, and that is going to bring it towards the armpit of Florida as a Category 1 hurricane. And then we also do have some tropical storm watches out for the coastal Carolinas already. And that's going to be for places like Charleston, even all the way up to Myrtle Beach and Savannah, Georgia, all under those tropical storm watches at this time. Would not be surprised to see those converted to warnings here in the next 24 to 48 hours. This is going to be a very interesting system nonetheless. And by the way, this cone of uncertainty also coincides with our spaghetti spread that we just talked about, in that it's this very broad area of the Carolinas where this system begins to slow down quite a bit. Notice how your cone really shrinks by the day, and that's because it's taking into account the fact that the system is going to slow down by the time we get to the early part of this week and also the middle of this week. So a couple other products I wanted to show you just to cap off some things, and then we'll dive into some weather model guidance. I think we'll call it a day. This is our bulk shear map, and let's slow this down. Actually, I'm going to stop it here, and we will back up. So it might be hard to see. Let's, don't want to do that. Let's zoom in, and if I can, let's see, zoom a little bit more. Okay, that's all right. If you can't make this out, this is Florida and the United States. All these colors here, first of all, these oranges are your wind vectors, and these colors, green, yellow, and red, are corresponding to wind shear. So what we're seeing towards Florida is, remember how I talked about that jet stream, right? We have this area of high pressure off the page in the Rockies. Let me draw that here in pink. Area of high pressure out towards the Rockies. Your jet flow, as we talked about the last several days, is riding over top that ridge axis and crashing down towards the Carolinas. You're going to see that jet stream show up because where we have our strongest flow is then going to correlate to our strongest shear. Keep an eye on this corner of the page up towards the Midwest as we loop it to right now. So as we go forward in time, these next couple frames, Look at that. So that is all essentially, it's a combination of our upper level winds, right? Essentially crashing through the Carolinas and bringing with it some frontal boundaries. But also because of that, subsequently, we have very strong shear, about 30 some knots that this system's going to encounter. Now, one thing that I mentioned though is with regards to the sea surface temperatures, they are very warm out towards the coastline. I mean, this is where the system's placed right now, just outside of those highest sea surface temperature thresholds, but look where it's going into. Very warm sea surface temperatures, but it's also going to be encountering shear, which is why a lot of the models have backed off on going any higher than a Cat 1. Because even though you have really warm sea surface temperatures, it's also going to be having shear that opposes it, and it's going to hit that system as it crosses over land. It's going to be interacting with land, it's going to be interacting with shear, and that's going to sort of keep this system at bay from getting any stronger. I do not expect this to undergo what's called rapid intensification. We're not going to see this thing jump from a Cat 1 to a Cat 3, and it's because, as we're observing right now, the shear is just way too strong. We're talking, close to 30 plus knots of bulk shear that's going to be opposing this thing as it moves over land. That is not a conducive environment for rapid intensification. However, because you still have a good sea surface temperature environment near the coastline, this system will still intensify despite the opposing shear. It just won't be as strong as, say, going from a Cat 1 to a major within 24 hours. That is very unlikely to happen. But you saw the shear, you saw the sea surface temperatures. Hopefully that all makes sense. There's a lot of variables at play as to why this system is not going to get any stronger than a Cat 1 and is really not expected to, quote-unquote, rapidly intensify by definition. So that pretty much concludes the tropical discussion on this system. Please let me know if you have any questions down in the Discord below. Like I said, this video was very granular. I mean, we talked about a lot of different products and many different variables here. We looked at observation in situ data. We're looking at model data here in just a bit. So if there's any questions, please let me know. And as I'm talking and doing this improv for you guys, I just remembered that there's 2 more products that I want to go through before we do wrap this video up. Let's first, out of those 2, take a look at the weather models on this particular system. So we'll go over to forecast models. We'll start first with the HWRF. We'll go over here to Debbie. And this takes us into Monday. You see that the HWRF has this at about a 979 and 982. Personally, I think the HWRF, which typically is a very bullish model, it has shown to be a model that does tend to go rapid intensification heavy, and it's got a bit of a bias there. I do not think we are going to get as intense as the HWRF is saying. I don't think this thing gets down to a 979. Right now we're about a 995. It's got too much shear against it. I think that realistically we will, the HWRF is kind of overdoing it. It's taking this kind of at a higher hurricane threshold, close to even like a higher end Cat 1, low end Cat 2. I don't think that's going to happen. I think we're going to be mostly looking at, if anything, a low end Cat 1. But that is the HWRF. As it goes through Florida, by the time we get to early this week, it then kind of slows down. And as you see, it stalls over Georgia and the Carolinas. This here is the biggest concern. Now, placement is going to be the biggest question mark on who is going to be pretty much under the system the entire duration of when it stalls. That still remains to be seen, but it's going to be anywhere between northern Florida and the coastal Carolinas that will be significantly impacted by that regardless. We can look at a couple others. The HMON is another different solution. And let's see here. This takes us in Georgia. This also has it not bombing out at a 979, but instead of 984. I think that's a little bit more realistic, being about a 984, 985. So I do tend to side with the HMON solution as an example. But also, just like the HWRF, this thing stalls, except the difference is the placement. It has it stalling more so over the Carolinas as opposed to northern Florida. Either way you look at it, impacts will still be significant nonetheless. And we'll take a look at one more here in the GFS. And we'll look at Debbie. The GFS, by the way, one thing I want to mention on this is quite fascinating. The GFS has actually been showing this system stalling out for the last week and a half. Or not even a week and a half, more like a week. it's been indicating that we could have a tropical system that stalls over the United States. So the GFS has done quite well with the handling of this system, I have to say. But just like the other two solutions, look at the placement for where it stalls. It's also different than the other two in that this one is off the coast of Savannah, Georgia, and the other two are in different spots of the southeast. So regardless of the placement, still going to be some significant impacts for the southeastern United States, especially towards the coastal Carolinas and Georgia and northern Florida. So that is going to be one of the more concerning things, aside from the initial landfall that's expected in the next 12 to 24 hours. The last product I wanted to show you, which I do not have pulled up here, is the Weather Prediction Center website. And this is a great resource because they also look at different products like flooding, and that's been one that I've been substantially talking about throughout the duration of this video. I mean, count how many times that I've talked about flooding here. So we currently have moderate risks and high risks for flooding in relation to Debbie, and the high risk has now been issued, and this includes the coastal Carolinas, particularly Charleston and Savannah, and those flooding concerns even get as far inland as places like Raleigh, Durham, and Charlotte. So this is a very high probability of precipitation. Let's go ahead and take a look at their weather discussion on that. So we'll skip ahead. This, by the way, would lead us to August 6th, and as we talked about, that's towards early to middle of this week. And so there's that high risk. I want to just look to see what their discussion is. It's rather short. And they don't mention it. Multi-day totals will be approaching 20 inches along the coast, with the heaviest focus over parts of Georgia, South Carolina, and extreme southeast North Carolina. They mentioned that in coordination with the weather forecast offices, they upgraded it to a high. And there's really not much to say here. There's no conversations. Typically, these weather discussions that the Prediction Center does, they're a lot more statistically technical. They may talk about for example, precipitable water being 5 sigma above the mean, like they did with the hurricane that hit Southern California a couple years back. In this case, they kept it pretty brief. They said, hey, there's just going to have a system that stalls over the Carolinas. It's going to dump a bunch of rain. I mean, there's really not much else to talk about there, right? That's pretty straightforward. You can't get any more straightforward than that. But these high risks are pretty rare that are issued by the Weather Prediction Center, and they have good reason to. We've clearly talked about the rainfall being a significant threat with a system that stalls. And that really is going to be the greatest concern, aside from this initial impact for the Florida armpit. I really need to get a shirt, Florida armpit. I think that'd be pretty cool. We'll see. I know Brian's the shirt guy. We should do a shirt for that. That'd be pretty awesome for Energy Rogue. But anyhow, listen. Thank you guys so much for tuning in. As I mentioned, I went over a lot today, and it may be kind of a lot to absorb. So if you have any questions or need any clarification on anything, especially as things continue to deteriorate throughout the day today and into this evening, just shoot me a question here on Discord. I'm happy to answer any questions you guys have. And as I mentioned at the top of the video, we're going to be going back to our temperature discussions once this system moves through, and that will take us probably into the middle of next week. But of course, if you have questions on that in the meantime, between now and then, just post those down in the Discord server. Thank you guys so much. I hope you guys have a great rest of your day, and we will be talking soon. And be on the lookout for another weather update. Take care.